Hey everyone, today I wanted to share my recent experience building a CLI tool with Deno and diving into the world of binary compilation for Deno. As someone who's always exploring new development platforms, I've got some pretty candid thoughts to share. For context, I've built CLIs in Rust, Dart, Go, a very tiny one with Zig, and we can compare it to that. So let's do just that. Okay, so this is the project that I built with Deno. It's called ADL. It's a tool for managing your architecture decision records. So I'll show you what you get from it, and then I'll show you some of the code. We can also talk about some of the things that I like too while we're here. So here's the README. It's ADL. It's pronounced ADL. It's a tool for managing your ADRs. These are architecture decision records if you're not familiar with them. This tool basically helps you generate markdown files and then catalogs them in a README. There's some install instructions here. This is kind of interesting. We probably should talk about this, but we'll come back to it in just a second. So if you install it, basically you can use the command ADL create, and then anything after that gets created into your ADR folder like this. And then you can call ADL regen to regenerate the README if you ever find yourself in a situation where you need to regenerate the README without creating a new ADR. So this is what you get out of the box. That's actually slightly behind. The most recent version puts together an assets folder here as well. And I'm using ADRs to document the development of ADL because that seems like the right thing to do. This is actually built for my project Dust. So that's over here. You should check that out if you have time. I think it's pretty cool. It's a digital collection of ebooks and digital comics. So you can kind of think of it as like Plex, but for things that you would read instead of things that you would watch. But yeah, here's an example of this actually being used in a more realistic setting. So there's an assets folder. I've uploaded this PNG of table structure. Here's an ADR right here. Use SQLite, some abstract, context, problem statement, considered options, decision outcome, table structure, stuff like that. Things that are really helpful to keep alongside your code base as your code evolves. That's not what we're here to talk about, though. We want to talk about building that CLI. So one thing I really liked about Deno from a CLI perspective is that I don't think I have any dependencies. I'm pretty sure I didn't install a dependency at all. And that may change. I may end up pulling in an arg parser dependency. This code is small. It's also a little messy. It's solving a purpose right now, and it's maybe not the most pretty thing. But yeah, I do pull in path from the standard library. That's it though. And this is a cross-platform path library, so it'll help join paths on Windows, Linux, Mac, things of that nature, so you don't have to worry about all the OS level specifics. I wrote a function that ensures a directory exists. That's it. I wrote a function that gets all the files in a directory. That'd be this one. Ensuring that an asset directory exists. A function called make new ADR. This is the bread and butter of that. Some writing to a file, rebuilding the README, same thing here, writing to a file. And then, a little bit more about Deno specifically, you can check if import meta main. So basically, if you're calling this as a main method, then maybe do something because you could export things here as well and not call it as a main method, like another project could import your script. So this is just a way to determine if your script is the one that is being the main executable. Yeah, sloppy arg parsing and a help command, sorry. And then just calling those methods that I built up above. Really clean. The code's not clean. Deno itself is clean, and I should clean this up at some point, which isn't really bad. So I was pretty happy with that. Where it starts to get a little trickier is I have this GitHub workflow that builds a Windows executable, a x86 Apple executable or Mac executable, and ARM64, like an M1, M2, M3, so on and so forth, version for Mac, an x86 for Linux, and an ARM for Linux as well. This is fine. There's probably a way to do this all in one command. I hadn't figured it out yet, so I just run these as separate steps. It seems to work fine. And then I use this release step to release all of these. So that's not that bad. Where it gets to be a little weird is if we look at the releases here, you can see the elephant in the room is that this is pretty large. Not the license. The license seems reasonable. So yeah, also the Windows one is missing, so maybe something is wrong there. I should look into that. But I'm on an ARM Mac, so if we look at the ARM Mac one, it's actually the smallest, but it's 65.6 megabytes in size, which is pretty big. I did a Hello World and did a binary compilation of that, and it was around 50 something megabytes, which seems pretty large for printing Hello World to the console. Part of Deno doing this though is that it ships with the entire V8 engine and Rust bindings for V8. Deno, like the core Deno functionality that's written in Rust. Yeah, quite a bit. So I like TypeScript, so I liked the opportunity to build this with TypeScript. But if I were to build the same thing with Dart and compile it, it would be a couple megabytes. And with Go, presumably even less. Zig, even less. And Rust would be comparable to Zig, I would imagine. I'm not entirely sure what the exacts were. So you might even wonder, why didn't I use Zig or Rust? If you're really curious, there's information on why to use Deno as an ADR. But let's compare it for a little bit. So if we look at this other CLI that I've written in Go, this is called Book. It's terminal-based bookmarks. They're different. They do different things. They're going to have a different amount of code. They're going to have a different amount of functionality. I totally get that. It's comparing apples to oranges. But at the end of the day, they're both fruit. So we can compare them at least a little bit. The Go code's really straightforward. There's a couple files here. We use structured logging. This is the only import that I have, external dependency. It's specifically for table formatting for output. It's really basic. It's not complex. In fact, if you look at this, I don't think it's much code either. There's a main method. I call some parsing from the flags library. Instead of pulling in something like Cobra, just decided to use flag from the standard library, which worked out really well. And then we just check and see what you're trying to do. You're either trying to delete all of your bookmarks, you're trying to list your bookmarks, delete a specific bookmark, have a path, so you're going to store a bookmark, or you're going to search or open. Those are your options. That's exactly what it does. Right out of the gate, you can see that there are more supported options for this than the Deno CLI. And again, they're not doing the same thing, comparing apples to oranges. The code for handling delete, handle delete all, handle delete, handle store. It's all right here. There's more code in the Go one, I guess is what I'm getting at. So if we look at, there's some paths stuff here. So getting the bookmark file path, the storage path, deleting a bookmark file, just some path logic, some storage logic here. And then, some small tests that I wrote. Workflow wise, what does it look like? Similar, but this uses a Go specific release called Go Releaser. This is really nice. That's all I really have to say about it. If you're distributing binaries with Go on GitHub, you should take a look at this. It's really nice. Let's compare them. So if we look at the releases here, you can see for context, this is it's a tar-gz, so it's zipped. And tarballed, so it's a little different, but let's see if we can I want to grab the Darwin ARM64. Let's unzip this. Take a peek. How big is this? 2.3 megabytes. So for comparison, this is about 25 times smaller than the Deno binary. I'm on an M1 Mac. I actually have the smallest storage option available. I'm not going to pull up my Mac information. That's a terrible idea because serial codes and all that. But the point being, I have a pretty good M1 Mac, but it's the smallest. Actually, you can see right here. It's the smallest. Oh my gosh, hard drive space that they ship with, and. I do music production, so I have Logic Pro on here. I do Flutter development, so I have Xcode and Android Studio, and I have Android images and iPhone images and iPad images. And then, of course, video editing, and I use Final Cut Pro for that. So I've got all of Final Cut Pro in here too. If I didn't have those things, I probably wouldn't have space concerns. But the point I'm getting at is, as a space-conscious individual, knowing that I've got a binary on my machine that is doing this, basically generating files and organizing them a little bit, and that's taking up 50-something megabytes, 56.4, I think is what we said. It feels a little bad. I think one more thing that I have from a complaint perspective is, so in the Node ecosystem, we have a tool called npx. And npx just lets you download a script and run a script. And you can make a million cases for why that's a bad idea, and you can make a couple cases for why it's a good idea. However, it is something that exists in the Node ecosystem. And I would love for Dust, which is also a Deno project. I mentioned this project earlier. I would love for people who work on Dust with me to not need to install Addle. And if there was something like npx, so like maybe dpx is what I'm going to call it, and you could just dpx straight to this script and run it, you wouldn't need to install the binary, which I think is nice. But there's not something like that. So you kind of get in this weird spot where in Node, you can just execute an arbitrary script. You don't really have that as easily as you can in Deno. I guess you could technically import the script and just call the main method on the script, or fudge something to make the script think that it is the main script being called. There's maybe a lot of options for that. I don't know, but they feel hacky. And so I have to build a binary from this and ship that. And I like having a binary. I like having that available as an option, but I would love to be able to npx or dpx this script and just run it instead of asking people to install this on their OS, especially since it's 56 megabytes. Again, most computers don't have an issue storing 56 megabytes, but it just feels big to me. Some pros, I like TypeScript. Deno, this was really great for prototyping. I was talking to a friend of mine and I couldn't decide between Zig or Rust for this, and he said just use TypeScript and just prototype the damn thing. So that's what I did. And I don't have a need to replace it because it works fine enough. Maybe one day it'll be rewritten in Zig or Rust, or maybe just Go. I've got options, but for now this is pretty sufficient, and it is a TypeScript's a language that I shouldn't say almost everyone, that a lot of engineers know. And if they don't know it, they can pick it up pretty quick if they want to make changes. And I cannot say the same for Zig or Rust. Probably could say the same for Go, but not for Zig or Rust, which, it's another thing to think about too. I really like Deno as a platform. So building this with Deno was really pleasant. Being able to use the JSR and just import like the Deno standard library, and then also the Deno built-ins like Deno lstat, Deno makedir, Deno readdir, Deno create for working with files, things like that. Really pleasant experience. The built-in editor, really nice. The built-in editor, the built-in formatter, really nice. The built-in test runner, really nice. I'm not using it for this project, but I do like it for other projects, and I will write tests at some point, I promise you. The linter, and then formatter, linter, test runner. Oh, and the TypeScript compiler. How could I forget that? Out of the box TypeScript, huge for me. But yeah, I guess so. My takeaway is like, I'm kind of mixed on my feelings for Deno as something to build binary executables with. I wish it was smaller. If it was smaller, I wouldn't even make this video. That's where I'm at. I really like Deno as a platform. I really like writing TypeScript. It's a great language. But the fact that I'm producing a 56 megabyte binary for a single TS file of 122 lines pains me deep down inside. And if you want to get particular, I know that Deno is looking into this. So maybe they will fix this. Maybe they will fix this, I say, like it's an issue. It is to me, but it is not necessarily an issue to them. Maybe they will investigate this and find a new solution to shrink the binaries. I have found people talking about one thing you could do is you could compile, or not compile, sorry. You could, there are like certain flags you can pass into the Rust compiler to drop debug information and shrink the size of the binary that way. And there's a lot of things, but like the short and sweet is that the devil is in the defaults, and the default produces a 50-something megabyte binary, which just feels bad to me. What are your thoughts? Am I being a little too uptight about binary size? It wouldn't surprise me if you said yes, but it matters to me. Let me know in the comments below. Thanks, and have a great day.